Okay, so welcome back. Now today we're going to start a new series where we're going to talk about the world of 3D. And you can see here the kind of stuff we're going to talk about. Where here is an animation I made in a 3D software called Blender. And we're going to talk about Blender, an absolutely wonderful free piece of software that does all kinds of stuff. All of this stuff was done in Blender. And you can build objects and you can put materials on them and you can light them and you can animate them. And we're going to talk about the entire world of 3D, and unlike a lot of videos you see on the topic that basically tell you, well, if you want to do this, press this button, and you're good. Like we do in most of our videos in this channel, we're going to try to explain what's going on under the hood so you actually understand stuff. You understand light, materials, and physics, and compositing, and images. And you actually know what's going on there, so you can do it yourself and not have to rely on somebody on the internet that, may not really know what they're talking about, but they'll give you an answer anyway. So if you haven't been involved in this 3D, I encourage you, if you're like me, you like technology and you like technical stuff and you want to add a little bit of art into your repertoire, it's a great thing to get involved in because you've got a lot of technology. You talk about lights, you talk about materials, and you talk about the real world and physics, and it really is a great opportunity to learn about things and to also exercise some artistic talents you might have. So in this series, we're going to talk about making models. For example, here's a little model I made of this Star Wars fighter, and if you've been around as long as you have, you probably remember back in 1977, I think it was, the first Star Wars came out, and surprisingly, here we are 45 years later, people still get excited over Star Wars. Go figure. But we're going to talk about making, this was a very simple model I made of a Star Wars fighter. We're going to talk about rendering, which means converting that into the image you see here. We're going to talk about animations, which is this this object in motion. We're going to talk about also compositing, which is a fascinating way to break down your image and your scene into different components, and you can modify those components to get the result that you want. And we're going to talk about, here is Blender. We're going to talk about how you can do all of that in Blender. And we're going to talk about compositing. We're going to talk about lighting. We're going to talk about materials, the different materials you put on your object. Video editing. We're going to talk about some tools like DaVinci Resolve, where you do video editing. What's called UV mapping, where you apply a two-dimensional image to your three-dimensional model. We're also going to talk about software like Nuke, which is free software that allows you to do compositing. So you've got a lot of free software like Blender and Nuke and DaVinci Resolve out there that will help you do all of this and put your artistic talents and your skills to work and come up with some really amazing stuff. So the first thing we're going to do is we're going to look at downloading the free and open source and absolutely amazing software called Blender that allows you to do a lot of that. So how do I get a hold of Blender? Well, you go to this website, which is blender.org, and you can see right here there's a big blue button that says Download Blender. And you click on that, and you basically click on this button to download it for Windows. You could also select Mac OS, Linux, other versions. Right now we're at 3.0. Your version may vary, but just download that and then you're all set to go. And this is what you're going to see when you open up Blender. Now, if you look on the internet, you will see a lot of videos on Blender. Unfortunately, from my perspective, most videos look at it from the point of view of, hey, what does each of these buttons do? And you can see here it's got tons of functionality, tons of buttons that can be extremely confusing. And I think the reason is because it's best to first focus on what problem are we trying to solve? What is this tool going to help us solve? Because really, at the end of the day, this piece of software is just a tool to help you solve some challenge or problem that you have to solve. So it's better to say, okay, what is the problem we're trying to solve? And once you know what you're trying to solve, you can say, oh, well, to solve my problem, I need this feature. And then you can say, oh, well, where's that feature? Instead of saying, well, I've got all these buttons that I don't really understand what they're doing, but I know that if I press this button, it will do such and such. So what we're going to do is we're going to approach this as first we're going to look at the problem we're trying to solve, and then we're going to look at the tool and see how it can help us solve that problem. So at the end of the day, what Blender helps us do is to generate images and videos. That's really the goal of this piece of software, to help you generate custom images and videos. And you can make the image and video whatever you want, and that depends on your skill and talent levels. So you can pretty much generate any image or video using this software, but again, you need to understand a lot of stuff and you have to have a lot of skills. And we're going to look at some of those areas and see if we can build up our skills to make some really nice images and videos. Let's start and see what kind of challenge we have here that maybe Blender can help us with. I've got this image here and I took it from a wonderful website called unsplash.com that gives you a bunch of freely available images that people have uploaded. We're going to look at what do we need to generate an image like this. Presumably Blender can help us generate a nice image like this. So if we wanted to generate in our Blender software an image like this, what would we need? Well, if you look at the image, you can see, first of all, there's some objects in here, right? There's a very nice car, and there's a building in the background, and there's some trees, and there's some ground. So the first thing we're going to need to do is we're going to have to somehow in our software generate those objects. So the software is going to have to help us generate objects. And we're going to have to know how to generate those objects using the software. Now, one of the major things about computers that people seem to lose sight of is that computers are basically stupid. Computers know nothing. So we're going to have to tell the computer about every single part of all of these objects in the image. Because at the end of the day, everything comes down to programming the computer to tell it what to do, and it's going to have to be very, 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 very specific. We're going to have to tell the computer every point in this car, for example, where it's located, and we're going to have to build this object, this car object, and tell the computer every single point on this car object where it's located. So we have to tell it a lot of information to define this object. And we're going to have to do the same for the building. And we're going to have to define the location of every point on this building face. And the same with the trees, all of the leaves and the limbs and the ground. We're going to have to define for the computer the exact location of every single point on these objects. That's very important to keep in mind. We're going to have to understand the object, and we're going to have to understand how to build this object to tell the computer to, put an object in our scene that looks like this. And we're also going to have to tell it about the surface of the object. So for example, here you've got a window that has a very sharp reflection of the light. And then here you've got another surface that is kind of a fuzzy reflection of the light. So we're going to have to define to the computer the characteristics of the surface of all of these objects. So we got a lot of work to do. I mean, we're going to have to define not only the physical design of these objects, but also the surfaces of the objects. So, number one, we're going to have to do a lot of work to develop the object. So what else do we need? Well, we see here that there's some light shining on the object, on the car, and on the surface of the ground and of the building and of the trees, and that light is bouncing off all of those surfaces and into our eye. We're going to have to also define lights, and we're going to have to understand how lights work. The lights have color and they have direction, and we're going to have to define for the computer in great detail what those lights are comprised of and how they operate. So we have to define objects and their surfaces, lights and their characteristics. What else are we going to have to define? Well, obviously the big thing is we're going to have to define a camera. So basically this image was taken by a camera, and it converts all the bouncing light coming from the sun or wherever. It bounces off these surfaces, and some of those light bounces go into your camera lens, and you press the button to take a picture, and that converts those light bounces into little pixels that are stored on your camera or your cell phone. And we're going to have to figure out how to do that in our software. Basically convert all those little light bounces on all the surfaces that go into the camera, convert those into an image. So these are the three major things we're going to have to look for in our software. We're going to have to know how to define the objects and their surfaces. We're going to have to define the lights and their characteristics. And we're going to have a camera or a perspective view that, you, the viewer, are looking at this scene. And we're going to have to design that camera and define it however we want. What we're going to look at is we're going to assume that this area that we're looking at is what's called a scene. So it's what comprises your objects and your lights and your camera. So we're going to have inside this scene all of these components, and we're going to have to specify for each one of them what we want, what object we want, what surface we want, what light we want, and what camera we want, so that the computer can say, oh, okay, so you want it to look like this, and then we're going to press the button, and the camera we developed is going to convert all that into an image. So now that we know what we need our software to do, it should be a bit easier to understand what it's doing, because it's trying to solve this problem for us. So now we're back in Blender, and we know that we need this software to allow us to define objects and lights and a camera, and to have a scene that holds all of those things. And if you look here, this is basically a three-dimensional representation of your scene. But instead of a nice car, we have a cube, and we have a camera over here where I can click on it with my left mouse button. Here's our camera, and here is a light. And all of this stuff in Blender allows us to take these three components and to specify exactly and to customize exactly how we want each of these objects to be, what parameters we want. Instead of a cube, we want a nice looking car. And all of this functionality in Blender allows us to customize each of these components in our scene. And at the end, when we've got them all customized, it allows us to press a button like we do on our camera and convert that view into a picture, an image, or a video. And what we've got here, what's called the default scene when I start up Blender, I've got these three components. They're not the way we want them, but at least they are set up. And what we can do is we can press the button on our camera by going up to this render and hit render image, or F12 is the keyboard shortcut, render image, and it will give us a render of the scene as it is presently set up. Again, it's not the way we want it, but you can see that it's got a light, it's got an object, it's got a camera, and it's got the ability to convert all of that into an image, which we show right here. So now the first thing we said that we need this software to do for us is to allow us to define the shape of, for example, the car or whatever object we want to put in our scene and take a picture of. So it gives us this default cube. So let's take a look at this cube and see exactly what it's comprised of that tells the computer, hey, in the middle of my scene, I've got this cube here. What does the computer need to generate this picture of a cube? So what I've done is I've tweaked the view of this cube to show exactly what we have told the computer that defines this cube. And this cube is defined by these 1, 2, 3, 4, 5, 6, 7, 8 points that define the corners of the cube. And these are called vertices. Each one is a vertex. So there are 8 vertices, and we need to tell the computer the position of each vertex, and it will say, okay, there's 8 vertices, and these are the positions of those vertices. So, okay, I know that I need to draw a cube with those corners, all right? Very, very important. So you can see here that there is data required for 8 points in order to define this cube. So somehow we're going to have to tell the computer the location of each vertex and what its coordinates are. So what do we mean by coordinates? Well, as with anything with computers, you have to give it numbers. You have to give it exact numbers or else it doesn't know what you're talking about. So to do that, we have our scene configured as an XYZ coordinate system, just like you have in the real world. So you can define any location in the real world by its coordinates, where it is on the x-axis, where it is on the y-axis, and where it is on the z-axis. Now in the real world, we're more familiar with things like directions of north, south, east, and west, and then up and down. So it's very similar in the 3D world, except they have assigned those directions as X, Y, and Z. So for example, if I'm standing here in the middle of our scene and I want to tell somebody, okay, go over here, you can tell them, well, go east for 1 mile and then go north for 2 miles, and you will get to the right location. In the 3D world, you can say go X1 and Z2, and it will get you at the same point. But at the end of the day, you have to come up with numbers for locations. And here we are using the X, Y, and Z. So for example, this point right here, this vertex, has an X, Y, and Z coordinate. If you look up here, the X is 1 meter. So it's gone 1 meter in the X, 1 meter in the Y, and 1 meter in the Z from this origin. So every point, you can see down here, it's 1 meter in the X, 1 meter in the Y, and -1 in the Z. And every point has associated with it 3 numbers, which are X, Y, and Z coordinates. So if we've got 8 vertices, and each one has 3 numbers associated with it, you can see that we've got 24 or 3 times 8 numbers that we have to tell the computer about so that it knows about where these vertices are. So there's a lot of data here. There's a lot of numbers, but the computer, again, is very stupid, and you have to tell it exactly what the numbers are associated with your vertices. Once it's got those locations, it can say, okay, well, I've got 4 vertices here, and I can now put in what's called a polygon or a face to make it look like it's an enclosed cube. But you have to tell it every single thing. You have to be very specific, and you can't leave anything out, and you can't make any mistakes, so the computer is going to do exactly what you told it to, and it's going to give you something other than what you want. Now, to show you that the computer defines this object by all those numbers associated with the vertices, what I can do is I can save this object, this cube, in a file that can be brought into Blender or any other application, and it will reproduce this cube exactly as it is here based on what's in that file. And that file is a simple text file that you can open up, and it looks like this. This is what Blender, how it identified that cube with all of these numbers. And the first 8 of these numbers here define the 8 vertices and their locations. We said it was 1 meter, 1 meter, and -1 meter. So the vertices locations are defined by these numbers. The computer doesn't know anything that it's a cube. It doesn't know anything. All it knows is that there are vertices at these 8 locations with the X, Y, and Z coordinates. And that's how it knows about the cube. Anything else it doesn't know. You have to tell it what the vertices locations are, and we talked about how it's got a surface that, you know, the car was a yellow surface. We're then going to have to tell it what surface color we want, and it will store that. But at the end of the day, it all comes down to numbers. Now, thankfully, applications like Blender make it quite a bit easier for us to define our objects But at the end of the day, it's going to come down to that as far as the computer is concerned, and you're going to have to know that. You're going to have to be aware of what the computer needs so that you make sure that when you're modeling and you are defining your object, you've got all the important data. Okay, so now let's say we've got our cube, but let's say instead of having 6 polygons or 6 faces, let's say that one of these faces, one of these polygons is missing. So instead of having 6, I've only got 5 faces. Well, how are we going to tell the computer to only draw faces or polygons between certain vertices? Well, as we mentioned before, it's all about numbers. So you're going to have to specify to the computer between, for example, these 4 vertices, draw a face or a polygon, or the other option is to leave it out and not tell it to draw a face between those polygons. So how are we going to do that? Well, we could say that, for example, between this vertex, this vertex, this vertex, and this vertex, draw a polygon or a face. We can't just say this vertex. We're going to have to specify the vertex. So up here we've specified the vertices by x, y, and z coordinates. What's a little bit better way to do that? Well, we could number these. You could say like this is vertex 1, 2, 3, and 4, and tell it between those 4 vertices, draw a polygon, and the same for the rest of these. And if we didn't want a polygon, we'd leave that out. So one thing we could do is we could, instead of identifying the vertices by their x, y, and z coordinates, we could also assign them a number, like vertex 1, 2, 3, and 4. So if you look down the bottom here, you can see there are these 1, 2, 3, 4, 5, 6 lines labeled F, and F is for face. And what this does is it tells the computer between which vertices do you draw a face. And what it's done is it has taken these vertices and assigned a number to them instead of these 3 numbers. And it basically says draw a face between vertex 1, 5, 7, and 3. And there's more information here, but you get the point. Now, since this is a simple text file and it fully describes that cube, there's no reason why we can't, for example, just delete some lines and save it, reload it, and modify our cube however we want. Okay, so now what I've done is I've saved and reloaded that modified text file that defines the cube, and you can see the faces we deleted are represented here by this modified cube. So really there's no magic here. It's basically just numbers, as with anything with computers. You're just telling it a lot of data to describe the vertices and the faces, and as we'll see later, you also have to describe colors and that kind of thing for surfaces. Now, keep in mind, if any of this scares you off, you're not going to have to deal with these every vertex and every polygon, every face when you're modeling. Like I said, there's a lot of tools in here to make it very much easier for you. But the purpose of this is to show you that there's really no magic going on here. It's just a bunch of numbers. And if you need to get into greater depth on these 3D models and for a better understanding, this should give you some relief that, you know, there's no magic going on here. And what's going on behind the scenes, you can access it and you can modify it and you can understand it a little bit better. So now to give you a little bit more insight into what's involved with these models, I've downloaded a reference scene or a benchmark scene, very famous scene for the for Blender with the BMW models. And I've gone through and I have taken a photo of it called rendering, and this is the result. You can see it's a beautiful model of 2 BMWs. And they've got different surfaces. You've got some glow in the headlights, and you've got some out of focus area. But you have to specify all of that to the Blender software. So you're going to have to be familiar with all of these different concepts of lights and cameras and how they blur in the distance and the different surfaces. At the end of the day, it all comes down to these vertices and specifying all the specifics about these. Keep in mind that somebody at some point had to go through all the effort to specify all of these vertices and these surfaces. So when you're doing these modeling in Blender or any other 3D software, it's going to take a lot of work. So now that we've got a little bit of insight into what makes an object in our 3D software, let's figure out what kind of functionality we're going to need in our software. So for example, the simple cube, what's the difference between this simple cube and say a very nice car model? First of all, you can see there's only 8 vertices, and the computer can't define the shape of a car with only 8 vertices. You're going to need a lot more vertices, and you're going to need to be able to move those vertices so that they all form the shape of a car. So what we're going to expect from our software application like Blender is that it's got a lot of functionality, a lot of features that allow you to not only add a bunch of vertices, a bunch of geometry, but also allows you to move those vertices and shape them however you want, and to make that as easy as possible. So in the next video, we're going to look at some of the features that Blender has to allow you to build models, because that's going to be one of the most important and primary features in our 3D software. So if you like any of these videos, I encourage you to like and subscribe, hit the bell notifications, and most of all, let others know that we're here so we get some more viewers. Really appreciate it. Otherwise, take care and have a really good day. Thanks.